Hi everyone, welcome back to Math 11. So in this section, section 5.3, we're going to be looking at standard deviation. Now before we continue with the example here, I just wanted to talk briefly about some of the definitions that we need to understand. So when we talk about statistics, we have either the population or the sample. So think of the population as everyone living, let's say in Canada, right? That's the total population of Canada. And a sample would be, we just sample 1,000 people from the whole population. So again, population is what's out there in the real world, right? So the total number, so this would be representing the population. Okay, and a sample would be just a portion of this population. So let's say we take a small portion from the total and we call this the sample. Okay, now we're going to need to understand this difference because there's going to be lots of other definitions later on, and there's going to be things that relate to the population and things that relate to the sample. Okay, so again, population, for example, is like completing a census. So you're surveying every single person in Canada, and a sample would be just doing a survey and maybe just collecting information from 1,000 people or 100 people and then extrapolate it to bigger size. Anyway, let's get back to the example here. So it says Canucks are one shutout goal away from winning against the Red Wings. The coach has to pick one player to shoot the final shot. The following data describes the shutout percentages of 4 Canuck players in the last 5 practices. So we have 5 different players: Burrows, Booth, Raymond, and Kessler. And again, the last 5 shutout percentages in the last 5 practices. So the first thing, the question says, how can the coach use this data to determine which player to pick? So if you're a coach, you want to pick the most consistent player. So how do you define who's the most consistent? So from what you know already from statistics, we can look at the mean, median, and mode. So the mean is the average, so we can start with that. So here I just made a little table here on the side so we can add it to our notes to find the average, which is the mean. So to find the average, you're going to add all the numbers together. So all these numbers together. So I'm going to add them and divide it by 5. Now I already did the math for this. So if I add 36, 41, 43, 39, 45, and then divide it by 5, I'm going to get 40.8. So it'll be percent. So this is all in percent here. And then I can do the same thing for the other players. For Booth, it's going to be 39.4. And Raymond is 37.2. And last one is Kessler is 34.2%. So these are the averages. So how can the coach use this data to determine which player to pick? Well, we could look at the average. We could look at the mean or the average. But this does not tell us which is the most consistent player. It just gives us the overall average for each player. For example, if you look at Burrows, he has the highest average, but he shot one day 36%, and the last day he shot 45, right? So that's almost 10% difference there. So these are pretty spread out values. And with averages, you can have really big spread or you can have really small spread. So another way would be to look at the range. So that would be another way to look at this data. So we can also, so the next question says, which player seems to be the most consistent? So we can look at the range. We could look okay. So again, the mean doesn't tell you who's the most consistent. So we can add a note here. We could look at the mean, but it does not show consistency. oops, I skipped the letter, consistency. All right, so we could look at a range, which basically looking at the highest and the lowest values and see how spread those are. But again, because we have multiple values, how do you compare all the values to each other, right? So the range may be okay for 2 values, right? If you only have 2 values, but you have 5 values for each player. So the range kind of doesn't help us either here. So in statistics, we have another measurement, which we're going to learn about here. And we call this, we use it to find to define which data set is the most consistent. We call this the standard deviation. So when we talk about standard deviation, we're talking about the measure of scatter of the data. So standard deviation, or SD, okay, is the measure of the scatter. So how scattered the data is of scatter of data. Okay, in relation to the mean. So in relation to the average. To the mean. So that's our definition for the standard deviation again. It's a measure of scatter of data in relation to the mean. So what does this mean for us? Well, if you have a low standard deviation, that means that the values are very close to the mean. They're really close to the average. If you have high standard deviation, it means that the values are more spread out, they're more scattered. So low SD means that the values are closer together or closer to the mean. And then high SD just means that the values are more spread out. So the values are further away from the mean. So again, they're more scattered. So that's what we're trying to find here. So how do we find the standard deviation of something? So here's our equation for standard deviation. Notice here we use the letter sigma, which looks like a little O with a tail. So you draw the O and then add a little tail on the top like that. So this is a Greek letter sigma, which is going to represent the standard deviation of the population. And then we have this capital sigma. So both these letters are sigmas. So let me write it on the side here. So this is kind of like an E. Okay. This is Greek or capital Greek letter sigma. And this represents sum. So whenever we see sigma, that means the sum of something. And then we have this, again, the other sigma, the lowercase sigma, which is like an O with a tail on top, like that. This is also lowercase. This is lowercase Greek sigma. So the lowercase Greek sigma represents the standard deviation. Deviation. Okay, so there's two Greek letters here, which are both sigmas. The lowercase represents the standard deviation of the population. The uppercase sigma represents sum. So the way to understand this, we have sigma equals to the square root of the sum of xi minus x bar. So what is this x bar? X bar is the mean of the sample. So let's write it all out here. So again, x bar, let's write it down here. So the x with the dash on the top is going to be the mean of the x values. Okay, so when I talk about x values, I'm talking about these values in the table. So we can call this R. x1, x2, x3, x4, x5, and so on. So we can do the same thing for all the other players as well. So that's gonna be our mean. So I already found the mean. I found my x bar for each player. Xi is gonna be again your x1 or x2, x3, x4, and so on. And then n is gonna be the number of elements. For example, we have 5 values for each player, so n would equal to 5. So again, let's write sigma is the standard deviation. Standard deviation. Okay, and then again, n is going to be the number of elements. X again would be data element. So it could be x1, x2, and so on. I is going to be the index. So basically it just counts. Is it x1? Is it x2? Is it x3? And so on. So in this case, we're going to start from I starting from 1. Notice here it says I starts from 1. And then it will go up to here, right? So x1 minus x bar, x2 minus x bar, and so on. And then the n value again is going to be the highest value for the number of elements, which in our case is going to be 5. So n is going to be 5 in this equation. So our index in this case, it starts from 1. We can start from 0, but normally when you start counting, you start from counting from 1, 2, 3, not from 0, 1, 2, 3. Okay, and again, the sigma, the capital uppercase sigma here represents sum of something. So the sigma is the sum. So this is also called sigma. All right, so those are all the definitions, and that's our equation for standard deviation. Now, you don't need to always use this and derive this value by hand. Most calculators actually have built-in function for finding the standard deviation. I'm also going to show you how to find it using a graphing calculator through Desmos. But first, let's do one calculation by hand and see how much work it actually takes to do this by hand. So on the next page, we have, again, the calculation for one of the players. So again, in our case, we have 5 values per player. So our I value is going to go from 1 to 5. So the following symbol, sigma, means that we're talking the sum from I, which is going to start from 1, to the value n, which in our case, n equals to 5. So you're going to go from 1 to 5. All right. So when you write the sigma and it says xi minus x bar squared, this means that we're going to do the following. So that's what it actually means on the bottom. We're going to write x1 minus x bar squared plus x2 minus x bar squared plus x3 minus x bar squared plus x4 minus x bar squared plus x5 minus x bar squared. Okay, so let's do one standard deviation for one player. I'm not going to do for each because it takes way too much work, but let's do one for Boros, which is the first player. So we know the mean. I found it on the previous page, so let me write it on the side. So this is going to be for Boros. Okay, here's what we know. We know that the x bar, the mean, is going to be 40.8. Okay, and the n value is going to be 5. And we know x1, x2, x3, x4, x5. So let's write those on the side here as well. So I have it in front of me. So x1 was 36. x2 was 41. And again, this is just from the previous page here. x3 is 43. x4 is 39. And x5 is 45. Okay, so let's write our equation. We have all information now. So here's our equation for standard deviation. So sigma, let me write it in red here, just the equation. So sigma equals to the square root of, here's what we're going to do. Starting I from 1, I equal to 1, all the way to 5. That's what we're going to do. And then we're going to write our xi minus x bar squared. All this is going to be under the root over 5, because n in this case equals to 5. That's what we're going to use. We're going to plug in the values into here. Now, before we plug it into the square root part, let's just do the part that's under the square root. Let's just do the sum. Let's just do this part first, write it out on the outside, and then plug in the square root and the 5. So let's do the sum first. So we're going to do this part here. Because that takes quite a bit of work. Okay, so x1 is going to be this number right here. So you're going to plug in 36 minus the x bar, which is the average, which is going to be minus 40.8, and square it. The next one is going to be, again, this is a sum, so if you have plus, it's going to be x2, which is 41, minus 40.8 squared. Then we have plus the next one, which is x3, which in this case is 43, minus 40.8 squared, plus x4, which is 39, minus 40.8 squared, plus x5, which is 45, minus 40.8 squared. Okay, so we have this sum, and again, you have to use your calculator for this. You're going to take the difference of each one, you're going to square each of the values, you're going to add it all together, and all of this, I did the math here already. Let's see. The first one equals to 23.04, and this all equals to 0.04, and all of this equals to 4.84, and all this equals to 3.24, and the last one is 17.64. All right, so that's what all of these values equal to. So let's add this all together. So all of this now equals to 48.8. Okay, and now let's take our equation with everything together and plug in the square root and the 5. So our sigma is going to equal to the sum, which is this number right here, 48.8, over 5. So as you can see, it looks quite complicated, but once you do the steps, it's just basically two numbers dividing and then taking the square root. So all of this equals to 3.1241. So that's our standard deviation for bars. So that's going to go right here, 3.1241. So as you can see, that's quite a bit of work just for one calculation. We had to deal with a lot of values. We had to do a lot of calculations just to get this. So how can you do this on the calculator? Well, like I said, each calculator is different, so I can't really explain how to use your own calculator. You can look at the user manual for it and learn, or you can use Desmos, which I'm going to show you next. So if you go to Desmos website, which is desmos.com, or you can download the app, either one works. If you go to the website, you can access it on any device, but you can also download the app. So here's the website. So this is the calculator. And you're going to go to the keyboard down here. You're going to click Show Keyboard, and then you're going to see there's an option for functions. You're going to click on functions, and it might first show this trigonometry, but you're going to click on statistics, so stats, and you're going to look for the button that says standard deviation P. So there's two of them, STDev and STDevP. You want the P one. So this one stands for population. Because we're treating our values as the whole population, you want to choose this one. So you're going to click on this, or you can just type it in. And here you're just going to enter the values for, let's say, borrows, just to double check that we got the same answer. So you're going to enter 36, you're going to delimit it with comma. So 36, comma 41, comma 43, comma 39, comma 45. So as you can see, I entered all 5 values and it calculated the standard deviation for me. So this is the same value that I got earlier right here. So I got 3.12, and this is the same value that I got using the standard deviation calculator in Desmos. So then we can do the same thing for the other players. We can do the same thing for Booth. We're going to enter as dev p. I missed a letter. Dev p. And then type in the values for Booth. So it's going to be 36, comma 39, comma 38, comma 41, comma 43. And as you can see, it'll show you the values right away. So actually it calculates them as you add the numbers. So for Booth, it's going to be 2.4166 and so on. So basically this is a lot faster than doing all of this calculation here, of course. So make sure you learn how to use your own calculator or use Desmos. So again, the value that I got for Booth was 2.4166, and then from Raymond I got 2.7129 and 1.1662 for Kessler. So I use Desmos for the rest of calculations. All right. So based on what we know now, we know the standard deviation for each player. So again, standard deviation measures the spread of data compared to the average. So if you look at all of these values, Kessler has the lowest standard deviation of 1.1, whereas Boros has the highest standard deviation. So the higher the deviation, the more spread out the values are. The smaller deviation, the more consistent the values are going to be, which means that Kessler is the most consistent player out of all the players here. So based on this information, who would you pick? Well, if you were the coach, you want a consistent player because you know what you can expect from them. So Kessler would be the most consistent one. Okay, even though he has the lowest average, but he is the most consistent. So sometimes consistency is more important about more than the average. So even though he has the lowest average. Okay, but again, he's the most consistent. So again, a low standard deviation indicates that most values of the data are close to the mean, and a high standard deviation indicates that most values of the data are scattered further away from the mean. So you can just say further away from the mean. So that's the important part from this lesson. Know what standard deviation is, how to find it using your calculator or Desmos, and then understand what it means in a context like this. So basically, it shows you consistency. All right, so for practice, make sure you do the practice questions. This is section 5.3. So read pages 226 to 232 and do questions 1, 5, 6, 9. Again, you might have to use Desmos for some of the SD calculations. So don't try to do it by hand. Just use Desmos for some of the questions where I ask you to find the standard deviation. Okay, if you want more practice questions, make sure you do more practice questions, right? This is just the bare minimum that I expect you to work on, but you can do more questions than this. Again, if you have any questions, make sure you post them in the comments as a reply in Teams.